Good afternoon, my YouTube viewers. It's Crystal here, and I just wanted to do another code review for you. And this one is going to be on principal component analysis because I've been going through a few of the things in sklearn, and principal component analysis is a type of feature selection. So if we come over here to the sklearn website, it talks about principal component analysis. It's a linear dimensionality reduction using singular value decomposition of the data to project it to a lower dimensional space. The input data is centered but not scaled for each feature before applying the SVD. It uses the LAPACK implementation of the full SVD or a randomized truncated SVD by the method of Halco et al. 2009, depending on the shape of the input data and the number of components to extract. It can also use the SciPy sparse LinAlg RPAC implementation of the truncated SVD. So notice that this class does not support sparse input. It says see truncated SVD for an alternative sparse input. And I have actually covered principal component analysis in the past, but I wanted to go over it again, and the reason why is because I'm going to be making a course on sklearn, and sklearn is one of the features of principal component analysis. So let's just look here. So they've got, this is something that I didn't fit in my principal component analysis, random state. That was something that I didn't put in there. So we'll just go ahead and put give this a try. Random state equals 42, and then we'll rerun it because I want to put random state in there. It says it's new in version 0.18. It's used when the RPAC or randomized solvers are used. And then so here's the attributes of it. And these are some more things that you can look at with principal component analysis, like kernel PCA, sparse PCA, truncated SVT, and incremental PCA. And so here's some sample code on principal component analysis, and here's some different methods that you can use with principal component analysis. So I personally don't use PCA a lot because I have some code that I use to get rid of redundant columns. But if you were very specific, if you wanted to be very specific in your feature selection, there are other methods in sklearn that deal specifically with feature selection. So this talks about feature selection, and these are all of the different methods that you can use specifically for feature selection, which we're not going to talk about in this video. But if you're interested in feature selection, this is what they talk about with regard to reducing the features. But as I said, I have a bit of code that I use. I haven't used it in this one that will get rid of redundant features. I have used it in other program, so you may be familiar with that code already. And that's what I personally do for feature selection. But if you're ever given an assignment to reduce the features to a very specific number of features, then you can use feature selection in sklearn. And I have used it before. So what we'll do now is we'll actually go over the code now that we've talked about principal component analysis in sklearn and also feature selection. So I've used the breast cancer data set and sklearn's toy data sets. And the reason why is because it's got a lot of features, number one, and two, is something that you can load directly from sklearn, so you don't have to go around looking for a data set to use. So the first thing we're going to do is we're going to import libraries. So we're going to import pandas as PD. Pandas does data processing, and in addition to data processing, it also creates series and data frames. And then we're going to import NumPy as NP. NumPy performs mathematical computations. It also creates NumPy arrays. We're going to import matplotlib.pyplot as PLT, and basically what that does is that plots the data points onto a graph so that you can visualize it. And then we're going to import Seaborn as SNS, which is another graphics library built on top of matplotlib, which also performs statistical operations. So after we've imported our library, what we're going to do is we're going to load our data set, and we're going to use sklearn's toy data set, the breast cancer data set. So cancer equals load breast cancer, and as frame equals true. So what that's going to do is that's going to put it in the format of a data frame. And then we're going to call up the print cancer keys, so you can see the keys are data, target, frame, target names, D-square, feature names, file name, and data module. So I wanted to print the feature names because I wanted to see what feature names I had to work with, and these are all of the feature names. So what I did was X is cancer data, that's your independent variable, and Y is cancer.target, that's your dependent variable. And I've checked the shape of it. So X is 569 rows by 30 columns, and Y is 569 rows. So now what I've done is I have shuffled the data frame. So DF equals X, DF target equals Y, DF equals DF.sample, brackets, frac equals 1, random state equals 42, DF. So you can see that we have shuffled the data frame, and you want to shuffle the data frame in the hopes that your accuracy will be higher if your data frame has been shuffled. So now what we're going to do is we're going to analyze the data. First thing we're going to do is we're going to use Seaborn to create a HIS plot of the target. And you can see in this particular data set, there's more people that don't have breast cancer than do. And now what we're going to do is we're going to just do a 2D representation of the ones and the zeros using matplotlib onto a scatter plot. So you can see that looks really good. And now we've got a 3D representation of the breast cancer data set. And so that looks really good too, so that shows you where it is in memory. And this is what I did. This is just, you can see, again, it's a 2D representation, and it's just a different way of looking at it. So it's a scatter plot between the mean area, the mean smoothness, and the worst symmetry. And you can see the ones which are green and the zeros which are red. And then what I did was I made a heat map really like heat maps. Heat maps tell you how the features or columns are correlated with each other. So if it's a light color, then it's got a really high correlation, and if it's a dark color, it has a low correlation. So there's your heat map. So now what we're going to do is we're going to normalize the data. So target equals df target, df equals df dot drop target axis equals 1, and then we normalize it, and then we make all of the data points a value between 0 and 1. And then after that, we put the target back into df target. And then so we had to do that to normalize it. So you can see here, all of the values in this data frame are between 0 and 1. So now what we're going to do is we're going to define our dependent and independent variables. And we do that by we shuffle the data set again, and then we take a sample, and the train is going to be 90% of the DF with a random state of 42, and val is we drop the train index, so everything that's left is your val. And then we set up our Y train, X train, Y val, and X val. The Y train is your target, and your X train is the data frame with the target dropped, and then your Y val is the target, and your X val is everything else from the data frame with the target dropped. So now what we do is we check our shape of these data frames. So X train shape, Y train shape, X val shape, Y val shape. 512 is X train rows, and then it's got 30 columns, and Y train has only one column. X val has 57 rows and by 30 columns, and Y val has one column. Now what we're going to do is we'll select our model. I chose Extra Trees classifier because it's a really superb classifier. It does a really good job. So model equals Extra Trees classifier, N estimators equals 500, random state equals 42, fit X train, Y train, and you print your model score, which is 1. And now what we're going to do is we're going to check cross-validation score, so you can see what the cross-validation score is. So your scores are 0.97, 0.94, 0.96, 0.96, 0.98, with a mean score of 0.96. And then your standard deviation is 0.0128. Now we check our Y-pred is our model.predict X-val, and so you can see all your ones and zeros, which is your Y-pred. We check our accuracy. Our accuracy is 98%, and now we put it on a confusion matrix, and when we put it on a confusion matrix, we only had one false positive, and everything else was a true positive and a true negative. And now we put it on a classification report, and then you can see the precision recall F1 score. Now what we're going to do is we're going to check principal component analysis. So what is supposed to happen with principal component analysis is you get rid of a lot of the columns, but you sacrifice accuracy when you're getting rid of the columns. So what we're going to do is we're going to see if that is true. So we call up our PCA from sklearn.decomposition import PCA. Tote train equals X train append X val. PCA equals PCA in components equals 2. Random state equals 42. Fit tote train. XPCA equals PCA dot transform tote train. And then we check our shape of XPCA, which is 569 rows by 2 columns. So let's come up here. Yep, 569 rows by 2 columns. So now we do a graph, put it on a graph with your X label is your first principal component and your Y label is your second principal component. Let me just, because I've just done this recently. So now what we're going to do is we're going to select our model and we're going to use extra trees classifier again. And we've got extra trees classifier. We're going to put it on XPCA to the length of X train and then Y train. And we have, we've trained and fitted the model and it has 100% accuracy. Now we're going to check our cross-val score. So our cross-val score is 90, 89, 94, 91, and 95. And so your mean score is 92. So let's go back and check the mean score of our previous one. And it was 96. So it's about 4 points lower with principal component analysis. And then we're going to check our Y-pred is going to be XPCA. It's going to be the length of X train to the end. So that's really the value, the number of rows of X-val and Y-pred. So you see all your ones and zeros and you check your accuracy is 96%. So we come back here and our accuracy is 98%. And with principal component analysis, our accuracy is 96%. So what we have done is we've sacrificed some accuracy to reduce the rows, reduce the columns. But you might come across a situation where somebody says, you've got lots and lots of columns of data, and somebody says that they want you to reduce the columns. And so you would use principal component analysis to reduce the columns with the knowledge that your accuracy was going to be lower. So now we put our Y-pred up into a confusion matrix, and now you have 2 false positives, whereas previously you had only 1 false positive. And then what we do is we put it on a classification report. So you can see the classification report is the accuracy is lower than it was previously. So that's the thing about principal component analysis. You may actually come across a situation where you are asked to reduce the columns. And when you reduce the columns, you can use principal component analysis. But there are also other things in sklearn that you can use as well. What I'm going to do is sklearn feature selection. And it comes over here to feature selection. And there's a page just on feature selection that gives you all this information that you need to know about feature selection. So principal component analysis is just one way that you can reduce the features. There are other ways as well, and you can find that out by going into feature selection. But what we've done is we've come into here, we've proved our principal component analysis, and you can see how you can reduce features using principal component analysis. So I'm going to go ahead and close this video because I've been talking for almost 20 minutes about this subject and other things. So I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you very much for watching this video. I look forward to making more code reviews for you in the future.